exception. And this is one of the runtime error because when you compile the code, you won't get any error, but when you run it, you'll get an error. And another error is permitted exception, which is divided by zero. You cannot divide by zero. And these are like hard-coded example. So usually we have a user input, and when the user enter, the user input is wrong. So to avoid that, we need to build a if else statement when we get the user input.
What do you say? You have to what?
You need to do the if else statement when you get the user input, or you need to use the try catch.
Yeah,
You use the try catch method.
right.
So to prevent these error. Why?
Or you write unit tests,
Yeah,
right?
yeah, your unit test. So I will go over it in the end. So
Yeah.
yeah. So another thing is a logic error. So logic error is, like I said, the code is nothing wrong, but I want to print 5 times. Inside in the loop, as you can see, from 1 to less than 5. So I only will print 4 times. So that will give me a logic error because nothing wrong with the program. And another thing is the infinite loop. So we all have infinite loop before. And the thing is we haven't checked the condition, right? So start from 0 and +2, so it skipped the 5. So it will be never 5, so it will run infinite loop. There's a logic error. So how can we prevent that? So for the runtime error, we can do the try catch as I said before, because we'll try this if the exception is popped up, it will catch the exception, and then it will you can do anything in the catch statement, and then why we do that? Because we don't want to crash the program. If we don't have it, the program will crash and we cannot use it. And for the logic error, we can do the unit test because in the unit test, you write separately with your program. So after your program is done, you run a unit test to pass all the tests to test your logic.
Very good. Okay. That's very good.
Mhm.
Okay.
All right.
Very good. Okay. Thank you. I like your background. Nice corporate. Okay. Um, okay. Someone's raising their hand or okay, so now I'm gonna share my screen and uh let's okay. Turn on my volume here. Uh and hide volume meeting controls. Okay. And I am recording, I believe, right? I think it didn't give me a warning, but I think I am recording. Uh yeah, I am. Okay, good. Um okay. So today I'd like to do let's see. Well, let's just begin where we left off, and then we left off with multiplicity. Do you remember that? That does that sound familiar? Oh, we thank you for your presentation. It was really- Okay, do you remember and you uploaded it, right, to the yeah, good. Oh yeah, basically, oh yeah, before we go any further, let's see, when is the midterm? So the midterm is going to be, let's see, check the schedule. Uh, um, let's look over here. Come on. Oh, there. Oh, I just had the schedule open. Uh, otherwise slow. Schedule and okay. So yeah, today is the 12th. Oh boy. So we only have 2 more classes. Okay. So we're gonna move. Okay. So okay. So first thing I want to do is just quickly go over the multiplicity. Okay, so what we're going to do is we're going to go to look at Google Images and let's just do a UML multiplicity. Okay, so um, So what is multiplicity? So let's do some images. So for example, let's look at this one over here. And um, okay, here we are. So over here, we're just looking at the numbers. Okay. So what is the relationship? Let's say I would ask, how many customers can an order have? What do you think the answer would be?
Much multiple.
How many customers could have, could how many could two customers have one order? Look at the diagram. You have to look at the diagram. Yeah. So the answer is no, because you see, from order to customer, there's only one, right? So order, and I can ask another question. Does the order have to have a customer? Right? Could you make an order without a customer? The answer again is no. So you could only have one customer. You have to have at least one, and you can't have more than one customer per order. Okay? Now, the other direction from customer to order, right? So let's look from let's say we're by the customer, we're looking at order. How many orders does the customer have to have? What's this least amount?
Customer doesn't need to order.
I'm sorry?
Customer doesn't need to order.
Doesn't need to order, right? Zero, right? And what is the most amount of orders a customer can make?
Infinite.
Infinite, exactly. Right. So, oh, you got how to read it. Very well. Right. So a customer could have, which makes sense. Like if you sign up with Amazon, the moment you sign up, you don't have any orders, right? You just signed up. Um, okay. And now let's look at order and order detail. How many order details, in other words, what is like, like order details, like, actually, let's look at item. So an item, so basically an order, what does that diamond mean? That clear diamond mean? It's it's aggregating. In other words, it's inside an order, our order details, right? And then an order detail is associated with a item, right? That's how you read it, right? So again, it goes from order, an order has order detail, and an order detail is associated with an item, right? So a so an order detail basically has, if you look at it, is only one item, right? It can only have one type of item. So what does the order detail tell us if it can only have one item? Well, the answer is it could have how many of them, basically. Quantity, right? And maybe tax status. I don't know what that would have to be with. I don't know why that has to do with order, whatever. Maybe it depends on your um, whatever. Okay, whatever. They put something there, which has to do. So basically, so let's say you go to Amazon, for example, and you order, let's say, three pens, two pencils, and one swimming pool. So that would be three, that would be how many items? There'd be three of one, three pens, two pencils, one swimming pool. So that would be how many items altogether? Be six, right? How many order details would there be? Three, right? And there'd be just one order, right? So there would so basically this is exactly what we're saying. We're saying that every order has to have at least one order detail, right? That makes sense because you can't have an order without anything inside of it, right? What are you ordering? Then within each order detail, you have to only have one item, right? At least this is how this company is doing it, right? And then if you go from the item, right, to order detail, right, some things like you go on Temu, I don't know how you pronounce it, Temu, Temu, right? Some things probably no one buys, right? So 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 an item, you could have an item, but you could have zero order details for it, right? Because no one buys it, right? So you can, or many people could buy it. So you can have zero to many, right? An item could be on many orders, or it could be on just one order, right? Or it could be on no orders, right? Zero or infinite, right? So that's how you read it. And an order detail could only be on one order, right? Two orders can't share the same order detail, right? And an order could have at least one order detail, and it could have an infinite amount of order details, right? So if I were to ask you, what's the maximum amount of items you could put on your order? The answer would be infinite, right? Because you can have infinite amount of order details, and each order detail could have has at least one item, right? Within you can only have one item. Well, it's not exactly composition. It's a association, right? So, but every order detail has to have at least it has one item associated with it. Okay. Um, okay. So, and then if we go down over here, we see how many ways could you pay for an order, right? Right, look over here. How many ways could you pay for an order? Or maybe do you have to pay it all? So you have to have at least one form of payment, but you could have infinite amounts of forms of payment, meaning that I could pay with a cash, three checks, and four credit cards, according to this, right? I have to pay at least with one of these, cash, check, or credit, right? They all inherit from payment, but I could use especially it's a big order, you could use multiple forms of payment, right? Like if you would buy you know, I remember the old days when you would buy a computer, it cost so much money, you would need like two or three credit cards to pay for it. Like they were so expensive, the old computers. Even nowadays, they're also expensive, but even then they were you get these big boxes of a huge box, and cost a lot of money. Uh, okay. Okay, so that's what we did last time. Okay, now I just want to do a little bit, two more, I want to do two design patterns. One of them is called the singleton pattern, and one's going to be cool, and they're both easy. Okay, so let's just do the two design patterns, singleton and the factory pattern. Okay, we haven't done it, right? I don't think so. No. Let's just go through that. Okay, and then we'll do chapter 3, and then we're ready for the midterm. Okay, so um, that's why I'm sort of running. What? Say again? I'm sorry? Oh, okay, so let's do a new project. Uh, a new project. Let's do let's do the easier one first, is factory. That's really easy to do. Factory pattern, spring 2026. Okay. Oh, I'm sorry. What happened? It wasn't. Oh, I didn't plug it in because I sat down. Okay, there we Okay, I'm sorry. Uh, oh, you weren't able to see before. I'm so sorry. Oh, okay. Uh, Oh, well, oh, okay. I'm so sorry. I unplugged it because he was the only one here when he presented. Okay, so so let's imagine we're going to factory. Okay, let's imagine we have I'm going to do bicycles, right? So let's say um, we have a tricycle that's for like little kids, right? And then we have a um, another type of bicycle called let's say a 10-speed bike. Like this is more for like older kids bicycle. And then let's do a third type called a e-bike. Okay. Okay. So over here, right, in Maine, if I want to create um, any class, I'm able to, right? I could create a tricycle, right? Right. Okay. So what is the factory? And or if I want, I could create a 10-speed bicycle. Um, right. So and let's give it some. Let's do something. Let's do a give it a method. Public void ride, and they'll just say something like S out riding my um 10-speed bicycle, and then we could just put this into the other ones. Right, so they all have this ride method. E-bike would have riding my e-bike, and tricycle would have um, riding my tri tricycle. Okay, so and then main we could whatever we could do like we could do tricycle dot ride. Okay, and then we could do right 10-speed bicycle dot ride. Okay, so what's the issue? Why do we need design pattern? This works really well, right? Well, the issue is that it's hard to explain when you're in college, but when you come to a company, imagine you came to a company, instead of bicycles, these were like database objects. And let's say you saw like four or five of them. You weren't sure which one to use, right? And there's no one really to ask what to do. So, or you don't feel like asking, you're lazy. So by accident, you could you could you could use the wrong object without realizing that you're using the wrong object, right? So I know that happens where I work. Like a lot of times I just copy code from somewhere else and I see how someone else did it somewhere else. I just copy that code and put it in where I'm doing. But sometimes I shouldn't be doing that, right? Sometimes it's probably I should actually know what I'm doing, right? Like instead of GTPing something without knowing what it's doing, you should maybe understand what you're doing, right? So, um, yeah, I was actually using ChatGPT today, and to do something I never really did. I went to see if it could do something, and it did really bad. I mean, it took a very long time, and I think if I would have done it by hand, number one, I would have learned something at the time I was waiting for it to do it, and I kept on trying to correct it and give it back to it and change it, and it got lost, and I ended up just doing, fixing it by it did some of it correctly, but but after a while, I just fixed it myself. So, yeah, so I think it's good for simple things, but like, like I was too lazy. Like what I was doing was a report, so I wanted to change the background. So to create the report, that's where ChatGPT, I spent like at least an hour on it. And it was just like every time I ran it, it didn't work correctly. And it kept promising, saying, well, if you want to do production code, I'll give it to you. Just ask for it or something. And it wasn't even working. Like, and I told it the error and it was doing this and that. And I don't know. I was very, not, I was very, and I was thinking, yeah, I probably could. I'm not learning anything, right? I'm just waiting for it to do something and it's not doing it. And so, but then once I had it working, I asked it, I was too lazy to figure out how to change the background color. So I figured all that ChatGPT could figure out how to do, right? So I said, take this document and change the background color. So that actually did well. Okay, yay. So, but in general, my belief is that you might as well do it yourself because even if it takes a little bit longer, but you'll actually learn something than if you stand around with ChatGPT and then say, oh, you made a mistake, fix it, and then still doesn't work, and you say, so instead of just wasting your time sitting there typing in commands, you might as well learn something, right? So that's what I think what I came out of after today's experience. Okay. Basically to do small changes, it's good, but to create something from, you know, just to create something, I don't think it's the greatest thing. Though some people say the opposite, that it's good at creating, like doing creating like the project and then, or like the main thing, like the main report, like the container for the report, and then you would add your own things. I found it the other way around. It's good. It's better at changing like small things, and like colors or probably width, some or maybe page layout stuff like that. I think it's better at, but doing like the actual creation of things, it's gets lost. Um, anyhow, so um, anyhow, so. Um, So what's wrong with this code? The answer is that there's really nothing wrong with it, but the problem is that there's no there's nobody making sure that there's no one checking to okay, so the problem with this code is that there is nobody making sure I am creating the correct bicycle, right? I might be, maybe I'm creating a 10-speed bicycle and I should be doing a tricycle. Maybe doing a tricycle and I should be, right? So there's nothing preventing me from, so that's why we have what's called a factory. And what the factory does is the factory will create these objects for me. So I'll show you how we do that. So for example, okay, well, in order to have a factory, okay, first let's create the bike factory. And what this factory makes, I know it's a strange name when you first hear it, but what it does is it creates bikes. And factory will create three different types of bikes, an e-bike, 10-speed bike, or a tricycle. So we could say you have like a method called create bike. And so we want, now the thing is, what is it going to return? So since remember, we're returning, um, we're going to return, well, let's look at the code for a second. Right now, let's make this void for one short second. Let's pass in some way which will tell the factory which one to create. So let's pass in age. like the age of the rider, okay? So if age is is less than, let's say, 5, let's let's do um, a new tricycle, right? And then if age is less than, let's say, 18, then we'll do a new 10-speed bike. Otherwise, we're going to do a new, um, we'll do a new e-bike. Now, the problem is we're not returning it, the object, right? New e-bike, the B is wrong, right? So what should the return value here be? Remember, we have 3 different objects, right? But they all have the same method, right? Called ride. What should they be returning? How do we group them together? How do we treat them the same? Beautiful. Right. You heard what she said? She said, right? Monica, right? Right. Monica said you do a interface, right? Because interface is how we group objects who have just like one or like something in common, but not a whole lot, right? In this case, they all have a method in common called what was it called? It's called, I forgot the name of the method. Ride, right? So we're going to create let's call um, create an interface called bicycle. And bicycle is going to have one method called ride. And then we're going to make the e-bike is going to implement bicycle. And then the 10-speed bicycle is also going to implement bicycle. And then tricycle is also going to implement, right? So now we have that. We go back to our bike factory and return, instead of a void, we could return a interface type, right? A bicycle. So so if it's less than 5, we could return a new tricycle. If the age is less than 18, we could return a new 10-speed bike. And otherwise, we're going to return a e-bike, right? So based on the age, we're going to create the um, the proper object, right? So now we don't have to worry about, uh-oh, this guy is creating an e-bike for a little kid. You're not supposed to give it, right? Or a 10-speed bike for a little kid, right? A little kid can only get a tricycle, right? So so how would that look in our code? So, okay, over here, we're going to comment it out for a second. And now we're going to create our factory. So we're going to say, what's it called? Bike factory. Um, bike factory equals to new bike factory. And then we're going to get bicycle. Remember, that's the type it returns. Bicycle equals uh, to bike factory dot create bike, and let's do for a 5-year-old. Okay, so uh, so if so, there's no one in the waiting room, right? I don't think so. No one in the waiting room. Uh, so um, so if we ride this bicycle, it's going to it should say um, it should say um, a tricycle. And or is it less than five? I forgot already. It's less than five. Oh, let's do less than six. Okay. And then if it's going back to Maine, if we do a different bike for, let's say, a 20-year-old, right? So if we do, if we go to the bike factory and create a bike for a 20-year-old, then we should be riding a, just tab that over. Okay, we should be riding an e-bike, right? So if we run this code, right, our factory is now going to create the proper bicycle that we should be riding, we should be using, right? There we go. So, um, right, so well, first it, um, first it created the tricycle, and then it created an e-bike, right? Because first, now, we just have to change one thing over here, which is that, remember this code up here, where we just created the objects without knowing exactly how they work, right? Over here, this code still works, meaning we could still, somebody who comes to a new employee could accidentally create the wrong bicycle for the wrong age, right? So how do we prevent that? So Java has a feature called a private class. So we could do is we could hide, we could take this class over here and we could put this inside the factory class. So it's only visible so it's a private class. And we could do the same thing with um, the other classes. We could make them private. So now we're really going to make sure that people can't create the wrong object. Because the only way they could create it is by going through our factory. In our factory, because now they're private inside the factory. So if we go over here, it's all going to be private. And now the Wild West is over. We can't go ahead and uncomment this code. Will not work, right? Because you can't create a tricycle anymore. You have to go, and even if we did bike factory dot, if I tried something like this, I can't do it because it's private. Well, I could do it on the left side, but I can't do it on the right side, right? Because it's a private object. So it won't let me do it. See? I can't create it. So now the only way to create a tricycle is through the factory. That's the only way I could do it. So we still run this code is making sure the factory makes sure that only the right objects are being created by me. I don't accidentally create the wrong object. So first I'm creating a tricycle, then I'm creating an e-bike. So this is a cool idea, I think, right? And there's actually another design pattern which we're not going to do, which is a factory that creates factories. I don't know. It's me. It's a little bit, yeah. Yeah. Then they'll have a factory that creates factory, whatever. Yeah. But there is a design pattern like that, like a factory that creates factories. So, um, but this is good enough for me. But this I understand. Yeah, this makes sense because this actually happens to me at work because a lot of times I don't know how to do things and I just look and copy and paste. And it's not good because, I could create objects, but someone else created it over here. But maybe where in my situation, it's not a good idea. Or a lot of times I'm looking at old code and that class object we stopped using it a while ago and they just left it there, and that, so where I'm copying from, there's a better way to do it, you know? So when you have a factory, that prevents you from just going on your own and just creating objects, right? Because at least in order to create it, I have to understand, that which object gets created is dependent on something, in this case, age, right? So if you have a factory, then it's not the wild, wild west. Okay? Now let's do another design pattern. Okay, so that's good. That's good. That's pretty simple, right? Nice little design pattern, right? So again, the main idea of the factory pattern is, I'll just write over here. Okay, so the factory design pattern controls which object gets created. Okay? So it basically makes things more safer, right? Gets created. It's basically for programmers. It's not for, users by the program. Right? So I can't just go ahead and start creating objects and, destroying everything. Okay, now let's do another one called the singleton. So the singleton is also pretty simple one. Okay, singleton, um, singleton, um, spring. Okay, okay. So basically, let's start out with this idea of a global. Oh, actually, let's say a statement, um, and a um, invoice. I don't know. Not important. I have like, let's say, and then, and basically every time I print a invoice, I want to, I need what I want to do is I want to have a unique, ID number for every statement and invoice that I print. Okay, right, that's all I want to do, right? So in other words, I don't want to have the same ID twice. Okay, so statements. So like, for example, if I print 3 invoices, there'll be 1, 2, 3. Then if I do some statements, it'll be 4, 5, 6, right? And right, so I'll have a unique ID for all my invoices and statements, right? So let me just go over here. So one way to do it is what's called using a global, which means in main over here, um, I could create a public static and ID. I'm gonna have to give it a type, and let's initialize it to 1. Okay. Okay. Um, or let's initialize 0. It doesn't really make a difference. Okay. And then when I print a statement, I could just say, printing. I forgot, I did it 0 or 1. Doesn't make, okay. So I did printing invoice number, and I'm going to do plus main dot ID, right? And then after I print it, I'm going to increment, right? You understand what the plus plus does? It'll increment it after it gets access. And then for a statement, I'll have the same thing. It'll just be a statement. It'll be printing statement number Okay. And then in main, I could just do um, statement, and I could do invoice. And so I could print a bunch of these, and then I could do an invoice I could print. And it's all going to be, they're all going to have separate IDs, right? So if we go and we run our code, we'll have a separate ID for every single one of these guys, right? So we'll have, um, right, so you have, right, so it goes in order. Uh, I should have done it one. Okay. Okay, so if we run it again, we'll start at one, and it's in order, right? Okay. Now, I don't know if you were taught this, but this is a really, really bad idea, this code. Okay? There's two reasons why this code is really bad. Well, first of all, what are we doing that's bad? Okay? So we're doing over here, we are using a global variable, which means global meaning that you notice over here it's available and basically it's available anywhere in the program, right? So we're using a global variable, which is bad for two reasons. Um, so um, bad for two reasons. Number one, a global it's nearly impossible to trace. Um, uh, uh, to trace when it is modified, right? So basically, in other words, in other words, for example, we're changing it over here, we're changing it over here, but it could be changed, right, through anywhere in the program, right? So it's just basically anybody that feels like saying, hey, let's change ID, they'll change it. And if you're trying to debug this, it's nearly impossible, right? Because it's all over the program. There's like a little code over here that this, let's say let's say I have, for example, I have a um, uh, uh, error handler. So my error handler, I spelled that wrong. My error handler could, for example, could handle, let's say it has a public method called handle. It could just say, you know what, part of whatever I do, handling error. And then part of what it could do is it could say, oh, ID should be, I'll just set it back to 0. Why not? Right. And and you're looking at your program, and let's say there's a error somewhere around here in the statement, and then and then all of a sudden your IDs start changing, and you have no idea where they changed, right? Because it's changed all over the place, right? So that's why it's a bad idea. So it's because it's impossible to trace not when it's modified, where it's, when it is modified, when and where, really. Well, actually, we know where, but it's impossible when it's modified, right? Right. So it's very, 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 very. I have at work. I have this old globals that I look at, and I just like want to get rid of them. But I'm just scared because I might break something. But I hate them because like I have no idea what it's doing. It's just like in the middle of nowhere. you see this equals to some value and you have no idea why it's doing it, it probably is, it was, the person who wrote it 10 years ago, he had a reason for it, but now it's probably, but I just too scared to get rid of it. I can't just delete it, you know, but, so like globals are really hard to, they're hard to figure out what's going on. So that's number one. What's wrong with this ID is that, and number two is, well, number one, it's impossible. It's very hard to trace. And number two is, basically any, uh, anyone can, change the global, right? To whatever value they want. Okay, so basically, for example, I could have somewhere else, like for example, this could make it, instead of 0, it can make it -10 for whatever reason it feels like it, right? Let's say someone accidentally typed in -10, nothing's going to stop them from doing that, right? So it's basically, you could, or it could say ID equals ID plus, could add 10 to it for whatever reason. I don't know. Add 100 to it, right? There's no control over what goes on, right? There's nothing checking to make sure that, this global has a correct value. So that's why we have the singleton. So singleton is basically a global, but a protected global. So we'll have a class we'll still have a global, but it's going to be a protected global. Okay, so we're going to call this, a method called getID. Okay, and within getID, we're going to have a global, but this global is going to be private, right? So it's going to be so static means it's global. You understand what global means? Global means that there's only one of them, right? And it's going to be, and we'll set it to, let's set it to 1 this time. Okay, but no one could touch it. Only who could touch it? Who could change ID? Only members of getID, right? No one else, because it's private, even so it's a little bit of a trick, right? So even though it's private, but it's global, meaning that in other words, when the program gets loaded, this ID will get created, right? And it will always you don't have to create this object to create ID. In other words, as soon as a program loads, even if there are no objects, called getID created, this will still be created, right? Because it's a static, but only people that could access it are who? The members of this method. So we can have a public method called, which returns an integer called get, let's say next. And what this is going to do is it's going to, return ID plus plus. Okay, so now you can't have like this type of code over here where we're modifying it, and we can't have code over here where we're modifying it, right? Instead, we're going to have something like this. Actually, I'll make it even simpler. We can make this into a static method, which means that I don't, have to actually, create this object each time I want to use it. I want to call get next, right? So and it's going to work because this is a static. Static again means global, right? You understand that? Does it make sense? I don't want to get too fast. And if this is a static variable, which means it's created when the program gets created. And this is a static method, which means, do you understand what static method is? Means that you don't have to create the specific object in order to call it. Okay? A static method is a method where you don't have to create the object that contains it. Okay, so I'll show you over here exactly how that would work. So instead of using our ID that we were doing before, we could instead do it this way. We could have printing invoice, and we could call plus get ID dot get next. Okay, so we're calling the object and the method, which will automatically, the get next is the one that modifies ID. No one else can modify it, only this method. And then we'll do the same thing in statement. We're going to comment this out, and we're going to do it using the singleton, and then printing statement. And again, we're going to call get ID dot get next. Okay, and then error handler, we're just gonna we're gonna just get rid of this code altogether. Or if we want, we could in get ID, we could say maybe have a reset method, maybe something called reset. And then reset will set ID equals to 1. Okay, but the point is, the handler can't directly do it. It could just, instead of calling this, it's going to call get ID dot reset. Okay, so it can never directly modify the global. And then our code over here is going to look cool, right? Because over here, it's going to work the same way it did before, right? But without using a global, right? Missing the return. Oh, should be void. Where's my main? Here we are. So if we run it again, we'll get, this time it'll work, but we're not using a global, okay? Okay, yay. So we get the same output, but without using a global, okay? Okay, so we're nearly done with singleton, except there happens to be two types of singletons. Okay, it was too easy, right? So there's actually two types of singletons. So again, a singleton, what does the word singleton mean? Singleton means, let's just write this down over here. Okay, so a singleton means that there is only one object created. In this case, there is only one variable that contains the ID, right? Okay, now we're going to have another type of singleton where now remember, what did I tell you? When does this variable get created? When the program begins, right? Because it's global. Globals get created as soon as the program loads, it allocates memory. You don't need to create this object. right? Even before this object is ever created, the ID is always created, okay? So sometimes, though, you can't create an object when a program begins. I'll give you an example. Let's say you're doing a database connection, right? So sometimes you can't connect to the database until after the program already begins, and then you have to like decide credentials and stuff like that, and you can create a database connection. But you only want to create a global connection, right? But you can't create it when you begin. You only want to create it once later on. Okay, so again, it's the same idea, I only want to create one, but rather than creating it when the program loads, I want to create it a little bit later on. Okay, so let's see how to do that. So let's create a thing called database connection, which is also going to be a type of singleton. And basically, let's say it has a method called um, it has a method, let's say, called connect, whatever, connect to database, public void. And this is how it's going to, but we only want to have one of these database connections, right? We don't want to have more than, right? We don't want to have um, um, two, right? We don't want to have three of them. How do we prevent our program from having more than one of these? Okay, that's the problem. So the way we're going to do it is we're going to have again, a global called another global private, private, and it's going to have a pointer, a reference to the database connection. Um, uh, it's going to have a pointer, a reference to it, and we'll call it, let's say, connection. Okay, and initially it's going to be equal to null, right? And then we'll have another method called get. Let me just make this smaller. We'll have something. Okay, so initially we're going to have a global called connection, which has a reference to our database connection. And then we're going to have another thing called public. This could actually be a, oh, I'm sorry. And, oh yeah, so we have something called get database, get DB connection, let's call it. Very similar to, right, what we saw before. And it's going to return a database connection. Okay, so it's going to return a new database connection. Okay, so how is this going to prevent more than one being created, right? If we call this multiple times, we're going to have, right, many database connections being created, right? So the answer is we're going to keep a pointer to our global, we're only going to have one database connection. So we're going to do like this. We're going to say if this equals to null, then we're going to say connection equals to new database connection. And then we always going to return underscore connection. So now we have a global, right? And we're saying that if this the first time we call get DB connection is that is the only time we're going to create it. Every other time we already have it, so we're just going to return the existing database connection. Okay? You see how this works? Very similar to ID, except because this is hidden, right? So no one has access to this connection object, and only this method over here has access to it, right? This is the only one that could create it, okay? And just to be really safe, we have to make the constructor, remember we did this by the factory, we're going to make the constructor to be private also. So we're going to have a private constructor to make sure that only this method is the only one that could create this database connection. So if we need a database connection to be created, we can only do it through here, and we're only going to have how many? Just one. Okay? So the difference between this method, so let's actually look at it. So let's just say like um, um, like so let's say for example we go to main. Where is main? Here. And we want to do let's do a database connection over here. So we have database connection, database connection equals to, and we do new database connection dot get DB connection. Oh, I can't even do that. Okay, wait a second. I can't do a new. But I could do I can't do the new because it's private. I have to do, I can't call it. So what I have to do is I have to make this, yeah, okay, I have to make this into a static, right? Because I can't create it, right? And then over here, I'm going to say equals to database connection dot get DB connection. Okay, so now I could do database connection dot connect. So even if I do this multiple times, I'm always going to be working with the, like for example, um, like for example, let's say I I want to what is it? Yeah. So let's say, for example, let's say I print out the let's say I print out the database connection over here, and I print it out over here. You'll see it's going to be the same object. You'll see what I mean in a second. So let's say we run this code. I hope it works. See if it figures out what to do. Yeah. So you look at this code over here. This is the memory of the object, and you see it's the exact same object in memory, right? So even though we called get DB connection twice, but only created it once. Okay, so wherever we do this in our code, it's always going to be the same object. So if let's say we do it over here, let's say we do it in this object over here in statement, let's say, it's always going to be the same memory address. So Oh, database connection. Yeah. Okay, so like it doesn't make a difference wherever we're going to call this code, it's always going to be only one object. So let's say we go over here. It's always going to be the same, see, the exact same object, same memory location, right? So only creates one database connection. Isn't that cool? So 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 we there's a so this is the second way of doing a singleton, right? First way is create it right away, and when the program loads. The second way is that you create it the first time you need it, right? First time we need a database connection, that's when we create it, but then we're careful to only have one of them, okay? Instead of, because a lot of times the reason why I'm using database connection is because a lot of, um, um, at least SQL Server, which I use at work, if you have too many database connections, or too many open ones, it slows down the database, or in fact, it might even crash. So you can't create too many connections. You gotta, close them up. So that's why this is a good example, because it's very common for a program just to need one database connection, right? Throughout the program, right? There's no reason to, usually no reason to have more than one connection to a database, right? Because you're just doing one thing at a time, right? Usually you're not like doing three things at once, right? You're not like reading like one thread reading one table, another thread, usually is have one database connection and you're doing one thing at a time, usually, right? Especially with databases, okay? Okay, so we're done. And then so we did, today we did a lot, right? We did multiplicity, we did, we did, we did the factory pattern, we did the two forms of the singleton, right? And and then next week, next Tuesday, um, we'll do the we'll do chapter 3, okay? So if you want, you could start reading chapter 3, and then hopefully that will be it before the midterm, okay?
And when is the new midterm date going to be?
I'm sorry?
Do you know when the new midterm date is going to be?
The new what?
Oh, because I remember you mentioned that it would be.
Oh, okay. So either I'm gonna do it, it's up to you. We can start earlier on Thursday if you want to do that, or we could do it on Sunday, before the midterm.
The midterm review or a Sunday midterm?
No, it's a midterm review.
Oh,
No, so we could do an extra, I want to, I'm committing extra time for the review. So I could either do it, or I could do both. Maybe let's try both. Let's try midterm review starting on, let's say a week from today. Let's, instead of starting at 8:30, I could start to review at 8, maybe. Does that sound good? Could people make it? And then we could do Sunday also if people want more review. I could do Sunday evening maybe, or Sunday morning afterwards, right? Because I think the midterm's on a Tuesday, right? Is that what it is? Hopefully it should be. Let's
yeah.
check. Yeah, it's on a Tuesday. Okay. Okay, so see you next week and we'll do chapter 3. Okay, and then we'll be done. Okay? We're ready for the midterm. Okay? So I'll see you. And I'll have a practice on Thursday or on Tuesday. I'll give you a practice midterm. Okay? So you could look that over also, okay? But right now, if you have a chance, look at chapter 3, okay? Um, okay, okay, see you back. Have a good weekend. Oh, yeah, that looks good.